Alright guys, welcome to the second video of this series on the relations of linear equations and lines. The second video we're going to be focusing on creating a table of value from the points on a graph. So we're going to use data sets and we're going to figure out points from there and what it would look like on a graph. To start off, creating a table of values helps us determine the equation of a line, and it helps us see really what's going on with the graph. You can use the ordered pairs, so the x and the y. Remember that the coordinates are represented as x, y. So this is your x coordinate, the horizontal, along here, this is x is 1, x is 2, x is 3, and the y is the vertical. All right, so the top row or left column in a table of values, so you'll usually see a table of values as a square or a rectangle or something like that, and the left one would be your x values, and the right one would be your y values. Okay, let's move forward. We're going to go through a lot of examples today, and there are going to be a few show you knows that you're going to try on your own. This does require graphing, so it's a great idea if you have graphing paper to do it on there. But if you can just make quick sketches as well to show that you understand, that works also. But it is preferable definitely to have graphing paper to work through these. Okay. So here's an example of what you would see for a table of values. It can be going sideways like this. It could be top down. They're all the same. It doesn't really make a difference. So here we're looking at Tony's Pizzas, the example from the previous video where we had the $9 pizza and $1 for each additional topping. So what we're going to do here is we're going to create a table of values, and we're just going to write out the cost. So if we had 0 toppings, that's one data point here, then the cost of the pizza is 9. And we know that because that's from the previous problem. If it was 1 topping, it would be $9 plus $1 because $1 per topping. So that is 10. Two toppings would be 11. And then it would just continue from there. 4, 5, so here we go, 12, 13, and 14. This way of doing a table of values is the same as doing top down. We just have to make sure that it is all done in the same way. 0, 1, 2, 3, 4, and 9, 10, 11, 12, 13. Now you'll notice that the x value, if you're doing it sideways, is up on the top, and it's on the left here. That just helps you read the points. So if you're looking at this as 0, 9, we're talking about the data point 0, 9. And that's the same thing as here we have 0, 9, and we're talking about the data point 0, 9. And we'll find that right here. Along the x-axis, we're at 0, and we're on the y-axis up 9. So this point right here is 0, 9. We'll do one more just as a review. Let's try 3, 12. So 3, 12. We go 1, 2, 3 along this line here, and 12 up. Here is 3, 12. Okay, that should be review. You should have done that a couple of years back, but it's always good to refresh. So creating a table of values, let's look at the points here. And what we're going to do is set up our table of values in the same way. So we had, if we're doing the one on the top here, we have the x-axis here, the x-axis, and the y-axis. And the x-axis, we could write what the values are, what it represents. So here it's toppings, but here it's the number of baseballs. Number of baseballs, and we represent that with B. And the y-axis is the total cost, and we're representing that in dollars. Okay, and I'll just fill that out here. Remember, the x-axis is the leftmost one here, and the y-axis is the rightmost one on that setup. I prefer these top-down ones because they're just space savers when you're doing graphs, but either one works. So this is number of, I'm just going to write baseballs, BB, just a shorten because I don't want to take too much time here, and total cost. Total cost in dollars. Okay. Now we got to find all the data points. So we have one data point right here that is at 1 and 3. So my x-axis is at 1. And it looks like it's at 3 here. So going upwards, it's 3. The next point, we have 2, 6. 2, 6. Oh, I missed the 3 there. 2 and 6. The next one is 3 and 9. And the last data point we have is 4, 12. Okay. And that's all you really have to do here. We're just using the data points to find out, like the data points on the graph to find out where the actual coordinates are so we can create a table of values. But you're also going to go backwards later on, turning a table of values into a line on a graph. And that's the graphing portion later. A quick review of the Cartesian plane. So the Cartesian plane is this thing you're looking at right here, going left and right along the x-axis, going up and down on the y. And all these quadrants, we reviewed this in the last video, all these are represented in Roman numerals. So you have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And it goes around like that. You cannot write number 1, number 2, number 3, and number 4. They have to be Roman numerals. Graphing linear equations. So we're going to move into the graphing part of it now. Table of values is pretty simple and straightforward to just find the points on a Cartesian plane. But to go backwards is a little more difficult for a lot of people. And this step, this is going to actually add a few more steps where you have to find out values. So remember in the last unit we did solving equations, we did a thing called substitution. And what substitution is basically where you take a value and you put it into an equation to solve for the other variable that you're missing. So here, what we're going to do is we're going to test a bunch of points. We're just going to say x is 2, or x is 7, or x is something. And when we do that, we throw it into our equation, and we're going to find out what y would be if x were that number. And so with that information, we're going to create a table of values of just random things that we selected, and that will allow us to put little points on our graph and create a line out of that. It doesn't matter what points you use. I could choose x is equal to 10 billion or x is equal to negative 333. But those would be kind of poor choices because my graph would look terrible. So usually you want to choose things that help you test a few things. 0 is a great one to test. Negative 2, negative 1, negative 5, negative 10, depending on what you're looking at. Or you might want to do the positives as well. So you want to test a few things on your line to see where it is, and then you can adjust from there. But really, if you know that it's a linear equation, you only actually need 2 points to make the line because it's not going to have any weird shape. The 2 points will go all the way through. But it does help to have extra points to just double check your work. So 5 is pretty standard. Let's try this out. Fill in the table of values by substituting x values into the equation. So I have x is equal to minus 2. Substitution, remember, I'm going to put that into the place of x here and see what happens. I'm going to do all the work here on the side just so that you can watch as it happens. I know for a lot of people this is going to be a little bit slower and you know what I'm doing already, but bear with me. So I'm putting minus 2 into the place of x. So this x is going to disappear. It will become minus 2. So y is equal to 2 times minus 2 plus 1. Now I can solve for y. Y is equal to 2 times minus 2 is minus 4 plus 1. So y is equal to minus 4 plus 1 is minus 3. And we would just fill that in here. That's one test point. So what this means is whenever x is minus 2, then y would be minus 3. Okay, let's test some other points, but I'm not going to do it quite in the same detail. You should have figured it out just from what I did here. So if I had x is equal to minus 1, I have 2 times minus 1. That's minus 2. Minus 2 plus 1 is minus 1. Let's try x is equal to 0. Well, if x is equal to 0, that's canceled out. So I just have y is equal to 1. And that's why it's really nice to have 0 as a test point, because that happens a lot. It makes things so easy. If x is equal to 1, then this is 2 times 1 is 2. 2 plus 1 is 3. And if x is 2, then 2 times 2 is 4. 4 plus 1 is 5. I have 5 possible test points. I've already filled in the table of values. Next, write the ordered pairs. Here's what I mean by write the ordered pairs. You're going to create ordered pairs out of these values. So I know that on my line, -2, -3 exists. So I have the point somewhere, -2, -3. I also have the point -1, -1. I have the point 0 and 1, 1 and 3, 2 and 5. Remember, these are all x, y. So when I go to do the next part, graph the ordered pairs, I have to remember that the first number is along the x-axis, and then I find the y-axis value as well. So I'm going to do this, graph the ordered pairs. -2, 1, 2 in the negative direction. Then I have -3, 1, 2, 3, 3 in the negative direction. So I have a point right there, -2, -3. I've done that. -1, -1, -1, -1. Check. 0 and 1. 0. So 0 along the x-axis and then 1 along the y. Check. 1 and 3. 1 and 3. Check. And 2 and 5. 2 and 5. Now, what I want to point out is, remember, this is linear, so it all has the same slope. It's going to make a nice line. And you also should be able to tell that the slope is, it rises by 2 and runs by 1. So the slope is actually 2 over 1 or just 2. Every one of these goes up 2 and moves over 1. So I know that there's going to be a point there. There's going to be a point here, and I can connect those dots. Now it's hard for me to do here. I'm going to try to make a nice line, but I'll probably fail miserably. Oh, it's not too bad. Hard to do on the computer, but so far it's okay. And try to get it as accurate as you possibly can so it looks good. If I had a line going off like this, that would not be very accurate. So try to make it as close as you can so it does show that you understand it's linear. Okay, so I've done all this. Connect the points to make the linear relation. Good. Moving forward. Okay, so we're here. This is a show you no problem. So this is one where I want you to pause the video, go through all the steps that I just did, which are fill in the table of values by substituting, write the ordered pairs, graph the ordered pairs, and then make your line. Pause the video and do that now. All right, you pause the video and you should have created a line that looks something like this. Now, I could be a little straighter here for sure, but it's tough to do on the computer. But hopefully you ended up with the same thing that I did here. Remember, these are x, y values. All right, here's your next one. Y is equal to x. Pause the video, give it a try. All right, so I'm guessing that you have finished now. And if you have done this, you'll notice that you have a really neat line where all the x values are identical to the y values. And that makes sense because y is equal to x. So you're going to have a line that goes, oops, I'm getting a phone call. You're getting a line that goes all the way through here just like this. Okay, and moving forward, you can pause the video. Oh, wait, no, this one is not a show you know. So let me just mute my phone here so I don't get that again. All right, so this one we're going to go through. We have minus 2x minus 3. So I'm going to substitute all these values. Minus 2 times minus 2 is positive 4. Positive 4 minus 3 is 1. Minus 1 times minus 2 is positive 2. Positive 2 minus 3 is minus 1. Then I have 0. That's going to cancel this out. I have a negative 3 here. 1 times negative 2 is negative 2. And negative 2 minus 3 is negative 5. Then I have negative 2 times 2 is negative 4. Negative 4 minus 3 is negative 7. So the next step, remember, is to create all the ordered pairs. So I have negative 2 and 1. I have negative 1 and negative 1. I have 0 and negative 3. I have 1 and negative 5. I have 2 and negative 7. Plotting all those points, negative 2 and 1 is my first one. Negative 1, negative 1. So negative 1 and negative 1. 0 and negative 3. 1 and negative 5. 2 and negative 7. So 2 and negative 7. Then from there, I can connect the dots and create a line. Let's see if I can do this. Come on, Mr. E. Come on, you can do it. Oh, that was actually pretty decent. Okay, I know this is going to stretch like that-ish as well. Close enough. All right, there's my line. And that is the line y is equal to minus 2x minus 3. Okay, another show you know. Y is equal to minus x. And I think you should be able to figure this out. Remember, you did y is equal to x, and you had those nice numbers where everything was identical. This is very similar, but it's y is equal to minus x. Pause the video, try this out. All right, here's what you should have gotten. It's very similar to the one before that went here, along here, y is equal to x was like that. It's the same thing, except it's flipped in a way. So everything that was negative for x is now positive for y. Everything that was positive for x is now negative for y. It's the same kind of line, just it's flipped. All right, and that was the last one, so it is time to stop.